Okay, so welcome to our session for today. So, good day everyone. So, today we are going to have the expansion of our discussions on properties of fluid. So, this time we are going to integrate the combined Boyles Law and Charles Law on gas. And then the properties of water. So, let us discuss the effect of factors such as temperature, pressure, and some other factors that may affect the value of specific weight of pure water. So we also discuss on this session the compressibility of water. In particular, we will have these learning objectives. So first, relate with the different variables involving the combined Boyles Law and Charles Law on gases. And then, of course, we apply the formula and be able to solve problems on Boyles Law and Charles Law on gases. And then we also have learning objectives on the definition of the bulk modulus of elasticity. So this refers to the compressibility of fluids. So let us have now this Boyles Law and Charles Law on gas. So we have discussed that a certain increase in temperature would mean a decrease on density or unit weight. And why is that? Because of intermolecular attraction. Of course, kapag pinainit mo or there will be a certain increase in temperature, the molecules will loosen. And take note, that would have a corresponding expansion on the volume. So, mag-expand yung volume, but it will have the same mass, no? Yung quantitative amount ng molecules is the same, considering that there is no evaporation. So, a certain increase in pressure would also mean an increase in density or unit weight. So, kapag in-applyan mo siya ng force or pressure, of course, our molecules will be compact, and that corresponds to an increase in density or unit weight. So, parang bibigat siya because of the pressure. And this is actually the combined Boyles Law and Charles Law on gas, wherein initially, sa previous discussion natin, we say that gamma is equal to the rho times acceleration due to gravity. And that could be equated to Pg all over RT. Ano yung P? P is the absolute pressure in pascals. R is the gas constant in Newton meter per kilogram Kelvin, wherein the Kelvin unit in temperature is degrees Celsius plus 273. So, ito yung constant ng R or the gas constant when we have an air that would equate to an equivalent gas constant of 287 Newton per kilogram Kelvin. Now, for the specific weight of water, it is affected by the following: the pressure, the temperature, and of course, the purity. Like for example, if we have 4 degrees Celsius, we say this is the normal condition wherein we can have a maximum gamma of 9,810 Newton per cubic meter. So a classic example for purity, of course, the gamma of seawater is much heavier than the pure water. Why? Because, of course, we know that there are impurities sa seawater aside from the salt content of the water. Well, specific weight of water, again, it is emphasized that it is affected by the increase in temperature. And as such, we have the corresponding values of the specific weight in gamma in kilonewton per cubic meter. As we can observe here, that as we increase the temperature, the specific weight in kilonewton per cubic meter reduces. Okay, so that is the effect of temperature. And again, it is stressed here that the molecules loosen, and because of that, yung specific weight, gumagaan siya. Okay? So, kapag gumaan yung specific weight, the same, yung density, parehas lang yan. Yung density kasi, it is a measure of mass all over volume. Gagaan din siya. Okay? So, moving on to the compressibility of fluid. So, for liquid, let us have here a piston. Now, itong piston na to contains brimful of water, no? And then, if we are going to apply an initial load to it, there will be an initial pressure on that. Okay? So, dito, wala pa tayong reduction in volume. But, if we tend to add a force, okay, a delta F, of course, there will be a volume reduction. So, the volume original minus a change in volume. And with that, nag-i-increase din yung pressure. So, pressure plus delta P. At yung for gas, similarly, pero mas malaki ang i-compress niya. Okay? It is also said na yung liquid, such as water, oil, and other liquids, are more incompressible than that of gas. Okay? So, very evident yung compressibility ng gas than that of the liquid. So, the role of bulk modulus of elasticity is analogous to Young's modulus of elasticity. So, in your strength of material, we are talking about solids, more on solids. Ano bang ibig sabihin ng Young's modulus of elasticity? So, Young's modulus of elasticity is a measure that a solid could resist a deformation. No? Kung mataas yung Young's modulus of elasticity niya, mataas din yung resistance niya in order to be restored back into its original shape kahit malaki yung loading. Kapag nirelease mo yung loading na yan, the same pa rin yung kanyang shape. So, meaning, it can resist deformation. But, if you exceeded that modulus of elasticity, of course, it will begin to lengthen, hahaba siya, or kapag compression naman yung force mo, it will be compacted. Okay? But, yun nga, sinabi ko, kapag hindi pa niya na-reach yung Young's modulus of elasticity, babalik siya sa original position kapag yung load is released. So, this is referred to as the incompressibility. So, meaning it is the degree of compressibility. No? So, it is a measure of the degree of compressibility. Hence, it is a measure of the ability of a substance to withstand changes in volume when under compression on all sides. So, it is actually equal to the quotient of the applied pressure divided by the relative deformation. So, yung general formula niya, yung bulk modulus of elasticity in megapascal is equal to negative delta P divided by delta V times the initial volume. So, where delta V is equal to the difference between the initial volume to that of the final volume, and delta P is equal to the initial pressure less the final pressure. So, all of this shall be applied to our examples today. So moving on to the examples. So this example is referring to the effect of temperature to the volume of the liquid. So remember, kapag pinataas or when it is heated or the liquid is heated, the volume expands. So, but the mass remains to be the same when there is no evaporation. So in here, illustrating this one, we have two distinct temperature. Initially, meron tayong 10 degrees Celsius at meron tayong 80 degrees Celsius. So at 10 degrees Celsius, say let us have here a cylinder filled with water. Okay, so the volume of this is 900 ml. The corresponding height is 90 centimeters. Okay, so 90 centimeter divided by 100, that is 0.9 meter. Okay, and itong 900 ml, para maging consistent tayo, i-meter muna natin lahat, no? So, yung 900 ml, we have 1,000 ml is equivalent to 1 liter, and 1,000 liters is equivalent to 1 cubic meter. So therefore, we have 9 times 10 raised to negative 4 cubic meter. So dito, this cylinder shall have its corresponding radius at 10 degrees Celsius. Now, this variable 0.9 here is the corresponding height at 10 degrees Celsius. So, if you can notice dito, coefficient of thermal expansion is given, meaning it will expand, ano? When it is heated in solids, when it is heated, it will expand. When it is cooled down, it will contract. So that is true to solids, and that was discussed in your strength of material. So ngayon, if we illustrate that one, lalaki yung ating cylinder because of the thermal expansion. So actually, this is just an exaggeration, no? So instead of labeling this as R10, itong R10 madadagdagan ng delta due to temperature, and this is actually the radius at 80 degrees Celsius. Hence, radius at 80 degrees Celsius is equal to R10 plus delta due to temperature. And recalling the formula for delta T, that is equal to alpha L delta T. Okay? At yung L dito, initially is the radius at 10. So, applying that formula, R80 is equal to radius at 10 plus radius at 10 alpha delta T. Further, R80, pwede nating i-factor out yung radius at 10 dito. What is left? 1 plus alpha delta T. So, delta T is actually equal to 80 final temperature minus initial temperature. So we have here 70. No problem sa alpha. Given naman yan. Okay, so we have here a relationship between R80, okay, R80 to that of the R10, radius at 10. We have 1 plus, ano yung alpha natin? 3.6 times 10 raised to negative 6 times 70. So this is the relationship between R80 and R10. Ano bang kinukuha natin dito? So the unknown here is the height of the water, the final height of the water at 80 degrees Celsius. Of course, sa loob nito, mag-e-expand yung volume, at the same time, nag-expand na rin yung glass, kasi glass yung material. What is our H80? So, this is the unknown in the problem. So, ngayon, kung alam natin yung radius at 80, makukuha na natin yung height ng 80 given the volume at 80. So, how is that? Remember that volume is just simply equal to area times height, or the base area times height. Okay, so we can write na yung area is a circular one, pi r squared h. Okay? So, paano natin magagamit yung 10 degrees Celsius, yung mga conditions dito? Simple lang. Let us say that the mass, remember, kapag nag-increase yung temperature, sabi natin, maglulusen yung volume, okay? Mag-e-expand yung volume, pero the same yung content niya, or the same quantitative measure, meaning, the mass at 10 degrees Celsius, no, is equal to the mass at 80 degrees Celsius. And mass can be expressed in terms of density, no? So remember that density is equal to mass all over volume. Kapag multiply mo yan, mass, solving for mass is simply equal to rho times volume. So meaning, rho at 10, volume at 10 is equal to rho at 80, volume at 80. So, ang kailangan lang natin dito is, what is the density at 10 degrees Celsius and the density at 80 degrees Celsius? So, referring sa table kanina, this one, kung titignan natin, ang value ng specific weight, gamma, at 10 is equal to what? Ito, 9.804. Palakihin natin konti. That is equal to 9,804 Newton per cubic meter. Kapag dinivide natin yan sa 9.81, magiging rho at 10 na yan. Okay? Rho at 10. Diba? So, we will have 999.39 kg per cubic meter. At yung rho at 80 naman, similarly, we divide 9,530 to 9.81. We will have 971.45 kg per cubic meter. So, knowing this, ano bang target natin? We are actually getting for the volume at 80. Diba? So, substituting the values here, okay, ito, 999.39, volume at 10 given na, ayan, 9 times 10 raised to negative 4, no? Rho at 80 is 971 971.45 times volume at 80, we can now get the volume at 80 in cubic meter. We have 9.26 times 10 raised to negative 4. So let us see what we have obtained here. No, 9.26 times 10 raised to negative 4. We can link that to radius at 80. So in here, we need to get our 10, no? Radius at 10. So paano na naman natin makukuha yung radius at 10? This one, volume is equal to pi r squared h. Kasi alam natin yung volume ng 10, alam rin natin yung height ng 10 degrees. So therefore, using this formula, at 10 degrees Celsius, we have 9 times 10 raised to negative 4. This is equal to pi radius 10 squared. Ano yung height? 10.9, no? So therefore, radius at 10 is equal to 0.0178. So kung alam natin yan, we can now determine radius at 80. Radius at 80 is equal to 0.0178 times this expression, 1 plus 3.6 times 10 raised to negative 6 times 70. Okay. Hence, radius 80 is equal to 0.0178 meters. So, kung titignan natin, halos parehas lang. Very negligible yung effect ng thermal expansion. Nevertheless, we can appreciate this more kung centimeter ang ginamit nating unit. At any rate, knowing radius at 80, we can link radius at 80 to that of the volume of 80. So what is the formula? V80 is equal to pi R80. This is squared. And ito na yung unknown, height ng 80. So let us substitute. 9.26 times 10 raised to negative 4. This is equal to pi r squared 0.0178 squared, height of 80, which is the unknown. Hence we can get for the unknown, height 80. So here we can get 0.929 meters. Okay. So ito yung unknown. So kung titignan natin, from 90 centimeter or 0.9 meters, height 80 would become 0.929 meters. Why? Again, nag-expand yung volume sa loob, but the mass is the same. So this is how to deal with a volume expansion of water or any liquid. Just remember na nag-expand yung volume pero the same quantitative amount or what we call mass. Okay? So moving on to the next problem. If a vessel that contains 3.5 cubic feet of water at 50 degrees Fahrenheit and atmospheric pressure is heated to 160 degrees Fahrenheit, what will be the percentage change in volume? What weight of water must be removed to maintain the original volume? So let us have here the vessel. So this vessel has a water content in it, say brimful, i-assume natin na puno yan. Okay? Puno yan ng tubig. So it is brimful of water. This is at 50 degrees Fahrenheit. No? So at 160 degrees Fahrenheit, what will happen? Kasi nga mag-expand yung volume, matatapon yung ibang tubig. So the condition is, ilan dapat yung kailangan mong bawasan dito, no? Ilan yung kailangan mong bawasan? So this, say this volume, delta V, para hindi matapon, or it will maintain its original volume when it is heated to 160 degrees Fahrenheit. Now, let us note here first na yung gamma dito is 62.4 PCF, at yung gamma naman dito, say gamma 50, gamma 160 dito is 61 PCF. Kung titignan natin, gumaan siya. Okay? So from 62.4 becomes 61 PCF because of the expansion of the molecules, but the same mass. So with that stand, we can say that gamma at 50, or the weight, sorry, parehas yung mass. Kung parehas yung mass, parehas din yung weight. Weight at 50 should be equal to weight at 160. Hence, what is the formula of weight in terms of gamma? Gamma is equal to weight over volume, no? Solving for weight, weight is equal to gamma volume. So, gamma volume ng 50 must be equal to gamma volume ng 160 degrees temperature Fahrenheit, in terms of Fahrenheit. So, substitute lang natin, ano yung gamma ng 50? 62.4. Okay. 62.4 times the volume at 50, ito given. So, by the way, meron kasing 3.5 cubic feet dyan. So, we have 3.5 cubic feet is equal to 61 times the volume at 160. So, eventually, volume at 160 is equal to 3.5803 cubic feet. So, maliwanag na talagang nag-expand yung volume. But it does not mean na bumigat siya. Okay? It does not mean na nadagdagan yung mass niya. At the same time, bumigat siya. So, that is not the case here. Nag-expand lang yung volume, but the same mass and the same weight. Okay? So, therefore, what will be the percentage change in volume? So, percentage delta volume i-subtract lang natin yung sobra 3.5803. Okay, nag-expand, no? By that difference, divide lang natin to sa original volume. So therefore, percentage delta V is equal to 0.02295. Multiplying that by 100%, we have 2.295%. So this is the increase or percentage increase in volume, in delta V actually. And then what weight of water must be removed to maintain the original volume? We say that weight is equal to gamma volume. So therefore, the weight must be removed, okay, is delta W, okay, and this is delta volume. Hence, delta W, gagamitin natin yung final temperature. Kasi nga, pinainit mo at this temperature, ano daw dapat ibawas? Ito, 3.5, 803 less 3.5. So, therefore, we have 4.898 pounds. So, this amount of weight shall be removed para pag pinainit mo yan, ito, eksakto lang dito sa mouth ng vessel. Okay, so that it will maintain its original volume. So that is how to solve this problem. So next problem, similar din to. A vertical cylindrical tank with a diameter of 12 meters and a depth of 4 meters is filled to the top with water at 20 degrees Celsius. If the water is heated to 50 degrees Celsius, how much water will spill over? So, ganun pa rin yung approach. At 20 degrees Celsius, meron tayong cylinder. Diameter niya is 12 meters. Yung height niya is 4 meters. Well, puno yan ng tubig. So, if it is heated to 50 degrees Celsius, we have the same cylinder, no? But of course, with the expansion of volume, no, may mag-spill over. So, what is this delta V? Delta V is actually the spill. Okay, so basically, again, we need to determine the gamma at 20 degrees Celsius and the gamma at 50 degrees Celsius. And now, of course, going back to the table, no? So gamma here at 20 is equal to 9.789 kilonewton per cubic meter. And yung gamma dito is 9.689 kilonewton per cubic meter. So again, the same weight, the same mass, but the volume expand, no? We can say that weight at 20 is equal to weight at 50. So by this is gamma volume at 20 and this is gamma volume at 50. Okay? So anong gamma natin? 9.789 kilonewton per cubic meter, no? Cubic meter natin ito area times height, no? Pi 12 squared all over 4, no? This is the area of the circle times height na 4 meters. So this is equal to 9.689 times the volume at 50. So we have here 457.06 cubic meter. So ito yung final temperature. So anyway, yung initial yung initial volume, no? This is the final volume. And the initial volume, ito lang naman yun, initial volume. So what is this value? So this value is actually the volume at 20, no? Equal to 452.39. So it is now obvious na from 452 naging 457. So therefore, delta V, yung natapon, is equal to delta V is equal to V50 minus V20, or that is 457.06 minus 452.39. Hence, the spilled water is equal to 4.67 cubic meter. Okay? So, that's all for the problem for today, and we will continue on the properties of liquid on the next session, particularly on the compressibility of fluids. So thank you for listening and have a good day again, class.